Imagine you're at a movie theater where the screen is 48 feet tall, mounted on a wall, so its bottom edge is 20 feet above the ground. Basically, here's the picture. 20 feet above the ground, 48-foot tall thing, and you do all this kind of stuff. Basically, here, let me show you the one that's moving and it's in motion. Let me go there. This one. You see, if you move this around, if you sit in different spots, how far away you sit from the wall, you get a bigger or smaller viewing angle. See how my viewing angle? See what it is up there, 32.09. Okay, it's getting bigger, bigger viewing angle, 33. Oh, now it's going down. So right around there, I got the biggest viewing angle. My eyeball, top of the screen to the bottom, biggest viewing angle, about 36 feet from the wall. That's whereas I go, really, really close to those terrible seats nobody wants, real close to the theater. You get a tiny little viewing angle, only like 12 degrees. Way back at the very back of the theater, you only get 20 degrees. Somewhere around there, right? 33 or so. It looks like my max right around there, around 36 feet away from the thing. That's maximum viewing. So that's the deal. We want to know where's the best place to sit to get maximum view. Maximum view. If you read through this problem, it basically says, okay, it says here's your X down here. X is the distance you're seated away from the wall. Most movie theaters actually the thing goes up, it doesn't go flat. That would make the problem harder with the angles. So I didn't want to go there. This person wrote the problem didn't want to go there. So real life you could do it. You just need a little more advanced math, but we'll just make it simple. Just pretend it's flat ground at a movie theater. That's not really what they do, of course. But anyway, if it was, you could still calculate it when it goes up, stadium seating. It's just a little more complex on the angles, and we got enough trouble. So flat ground, let's say movie theater. What's the best position X so that we can maximize our viewing, right? Want to maximize our viewing angle. This is our viewing angle, theta, right there. How much we can see the screen, viewing angle. I want to make that as big as possible. Okay. Well, anyway, we did the setup on another problem. And there it is. There's the formula for the viewing angle, theta, in terms of x, where you're sitting, how far back from the wall you're sitting. There it is. So now we just want to maximize that thing. So this is the conclusion. So let me write it down. We want to maximize theta equals inverse tangent. And I'm going to write that 68x to the minus 1. You know how I don't like fractions, they're a pain. And that one is 20x to the minus 1. Okay, so we want to maximize that thing. Well, to do that, you know how to maximize things? We got to take the derivative and set it equal to 0, right? Because when, at the top or the bottom, like of a roller coaster, the slope is flat at the top of it. The maxes and the mins get a flat slope. You get a derivative, which is the slope, equal to 0 at the top and the bottom, the maxes and mins. So if we want to find the maximum, I take the derivative set equals 0. Now, how do we take the derivative of tangent inverse? Well, we had the formula a while ago. I'll remind you. Derivative of the tangent of x, the derivative is 1 over 1 plus x squared. So that's the derivative of tangent inverse of x. I go, oh, okay, that's not too bad. So I'm going to go 1 over 1 plus, and then you got to take that whole argument, 68x to the minus 1 squared. But that's not all, because the inside was not a simple x. The chain rule says times derivative of the inside. What's derivative of the inside? Minus 68x to the minus 2, right? That minus 1 comes down. Subtract 1 from the power, right? Don't forget the chain rule. So the general rule for tangent inverse of anything is 1 over, you can just put, if it helps you, you can just put a blank there. You realize that x's in math science formulas are just blanks. So we're just saying, hey, if you're taking the tangent inverse of anything, the derivative of it will be 1 over 1 plus that thing squared. So tangent inverse of this is 1 over 1 plus that thing squared. But then the chain rule says, yeah, but don't forget about me, if the inside of anything you're doing is anything other than a simple x, then you go times derivative of the inside function. Minus 1 comes down, subtract 1 from the power. There we go. So I'm just going to make life easy. I'm just going to put that on the top because it's over 1, right? So let's just put it up here. In fact, well, maybe I'm doing too much too fast. I'll leave it there for a second. Plus or minus, minus right there. Now, excuse me. The same thing here. Gotta go. 1 over 1 plus the argument squared. That's derivative inverse tangent. But because of the chain rule, times the derivative of the inside function right here. Chain rule says if the inside is anything other than simple x, take the root of the multiply by the root of the inside. There we go. That minus 1 comes down, subtract 1 from the power. Right, righto. Okay, that's over 1. That's going to go up here to the top. This is going to go up here to the top. Okay. Oh, and we're not done. Set it equal to 0, right? We're supposed to take the derivative, which is all this stuff, and set it equal to 0. I want to know where's that derivative 0? Okay, well, we got a bit of work to do here. So let's do it. So coming in here, and this is going to be minus 68x to the minus 2 over 1 plus 68. I'm going to square that, x to the minus 2, right? I'm just going to say square the 68, square that. This is going to be minus, let's do a different color here if it's helpful. 1 over, well, actually that minus 20 is going to go to the top, huh? So let's do that. Minus 20x to the minus 2 on the bottom. We've got 1 plus, I'm going to square that. 20 times 20 is 400. You check on decimals if you're not sure. Minus 2 equals 0. Now, I'm going to go like this. Positive, right? Negative, negative. Head to head's positive. Those become positive. Okay, so I'm going to jump this guy to the other side and he'll become positive. So then I've got 1 plus x minus 2, 20x minus 2 equals, I just brought this guy right there. And the other guy jumped to the other side. And we've got minus 68x minus 2 over 1 plus 68 squared x minus 2. Now, can we cancel like 20 into 400 or these guys, x minus 2? No, because of the pluses. Same thing here. Plus, you can't cancel the 68s or these guys. No, no. Remember, when you have pluses and minuses, you can't cancel things. You can only cancel multiplied items, not added, subtracted items. Well, then what are we going to do? I got a trick. See how these both have x to the minus 2? You know what that means? Let me rewrite it. That means this is 20 over x squared, right? Because negative powers jump to the bottom. Same thing here. Negative 68 over x to the minus 2 is negative 68 over x to the positive 2. That's right. That's what negative powers do, right? Negative powers are unhappy where they're at. They jump to the bottom like that. And you might say, well, shouldn't it go to the bottom of the hole? You could. Yeah. In fact, you totally could. I should probably do that. All right, great. I'll do that. So this will be 68, and then this, or sorry, I'm doing the wrong one. I'm getting totally lost. It's this guy, huh? 20, and x to the 2 goes down there. And this one over here should be, it's this guy, that one over there. So that's now he's plus 68, and down here, x to the 2, because the x squared jumped down there. Right. Okay. Yeah, let's just do that. That's probably easier. I'll just do that. I forget about my trick. We'll just do that. I like that. Okay. Good. Now, this is going to sort of boom, boom, right? Okay. And so what's going to happen? What's going to happen? I'll just leave the tops the same. This is 20. This is 68. This is x squared times 1. This is going to be x squared plus 400. Ooh, did you see that? What happened there? 400 x to the minus 2 and then x to the plus 2, right? This x to the plus 2 hit that, and then hit that. So both those powers add, that's x to the zero. Anything zero power is one, it's gone. You can go times one if you want, right? Because it becomes 400 x to the zero. Remember, powers add. And x to the zero is one. It's just 400. Don't even need that. Same thing here. Boom, boom. X squared plus 68 squared. It's going to be 68 squared, x to the minus 2, and then the x to the other 2. Those will add 68 squared, x to the 0, which is 1, so it's just 68 squared. That's nice, huh? Okay, now let's go diagonal, diagonal. So 20 x squared plus 68 squared equals 68 x squared plus 400. Distribute. We're getting close. 20x squared plus 20 times 68 squared equals, boom, boom, 68x squared. You might wonder, why are you leaving that 60 squared? I just don't want to go to Desmos, you know? Same thing here. I'm going to go 68 times 4. I'll do Desmos at the end. Whatever it is, it is. Okay, what am I doing now? Well, notice I got a couple x squared, so I'm going to subtract 20x squareds from both sides. I'm almost there. So this is going to give me, what's that? 48 squared, and then subtract this other thing, this minus 68 times 400, minus 68 times 400. I'm going to go hit Desmond now. 20 times 68 squared. Let's go. 20 times 68 squared. So 20 times 68 squared minus 20 times 68 squared minus. So 20 times 68 squared minus 68 times 400. Minus 68 times 400. 68 times 400 is 65,280. 65,280. So, whoops. 65,280. Last step, you know it. Oh, no, we're not in last step yet. Divide by 48. Let's go see what that is. Divide by 48. So I'll take that answer divided by 48. And I'm getting 1360. It's nice, it's clean. Now the last step, you know it. We're going to root it, root it, root it. So x equals the square root of that 1360. So I'll go square root of answer. Boom, there it is, 368781, 368781, 368781. Is that the real answer? 368781. Yes, it is. That's the best spot to sit in the movie theater. You should back up your chair 36.8781. You'll have the best viewing angle. Is that what our little fooling around kind of showed us right here? Oh yeah, well, yeah, 36 feet. See that? See what's on there? See how we got that? 36 feet about was our best viewing angle. We could tinker with it a little bit, right? See that? See we get the highest there, right there, 37 feet. So maybe 37 feet. You get the best viewing angle, 33 pointers at the highest viewing angle. That's pretty close. We found out using calculus, the exact is actually, it's not really 37, it's 36.878, I don't know if you're going to measure that out and sit there, but really, you're not going to do any of this at the movie theater. This is more for like, when they create computer optics, and they do things like that, and sighting and targeting and all kinds of things in real life. That's how so we found the maximum viewing angle is when you scoot your seat back 36.878 feet. The math was a little tough, but this is calculus. So there we go.